Hi guys, welcome back to my YouTube channel. Today we are talking about the diffusion of gases. Prior to discussing diffusion of gases across alveolar membrane into blood, it is necessary to introduce the concept of partial pressure. According to Dalton law, the total pressure of a gas mixture is equal to sum of pressure that each gas would exert independently. Thus, the pressure that each gas exerts independently can be calculated by multiplying the fractional composition of gas by absolute pressure. Barometric pressure. Let's consider an example calculating the partial pressure of oxygen in air at sea level. The barometric pressure at sea level is 760 mmHg. The barometric pressure is the force exerted by weight of gas contained within atmosphere. The composition of air is generally considered the gas nitrogen carbon dioxide. Therefore, the partial pressure of oxygen at sea level can be computed. PO2 partial pressure of oxygen and multiply by and get the exact value of P dry atmosphere partial pressure of oxygen multiply plus partial pressure of nitrogen plus partial pressure of carbon dioxide. Diffusion of gas across tissue is described by the Fick law of diffusion, which state that the rate of gas transfer is proportional to the tissue area, the diffusion coefficient of gas, and difference in the partial pressure of gas on two sides of tissue, and is inversely proportional to thickness where A is the area and T is the thickness of tissue. D is the diffusion coefficient of gas and P1 minus P2 is the difference in partial pressure between two sides of tissue. In simple terms, the rate of diffusion for any single gas is greater when the surface area for diffusion is larger and the driving pressure between the two sides of tissue is high. In contrast, an increase in the tissue thickness impedes the diffusion. Their lung is well designed for diffusion of gases across alveolar membrane into and out of blood. First, the total surface area available for the diffusion is large, and the second, alveolar membrane is extremely thin. The fact that the lung is an ideal organ for gas exchange is important during maximal exercise. The rate of oxygen uptake and carbon dioxide output may increase 20 to 30 times above resting condition. Amount of oxygen and carbon dioxide obey the rule and depended on the temperature too of blood, the partial pressure of the gas, and solubility of gas. Because the temperature of blood does not change a great deal during exercise and solubility of the gas remain constant. The major factor that determine the amount of dissolved gas is partial pressure, and the gas move across the blood-gas interface in the lung due to simple diffusion. The rate of diffusion is described by Fick law, which state the volume of gas that move across a tissue is proportional to the area for a diffusion and the difference in partial pressure across membrane and inversely proportional to membrane thickness. Thank you so much guys for watching and must subscribe my YouTube channel.